Hey you guys, in this video we are going to look at adding, subtracting, and multiplying radical expressions. Alright, so when we go to add and subtract radical expressions, we can only combine like terms. So for example, the square root of 2 plus the square root of 2, or the cubed root of 5 minus the cubed root of 5, but not something like over here, the fourth root of 71 plus the fourth root of 63. We need the number under the radical, which is the radicand, and we need the index to match. We're going to treat the radical as if it is a variable, and we're going to add and subtract the numbers in front, or the coefficients. Alright, so I'm going to work out these 3 examples, and then there'll be 3 examples for you to try. So in this first example, we see that we have the radicand the same, and we have the index the same. So I'm just going to combine the coefficients, and in this case we're adding them. So 3 plus 4 is 7 times the fifth root of 21. I kept the like term. In the next example, we don't have the same radicand. So we're going to try to get the same radicand. We see our index is the same, and I'm going to go ahead and break down the square root of 18 to see if it could have a radicand of 2. So using the border method, I know 2 goes in 9 times, 3 goes in 3 times, and 3 goes in once. So a 3 can come out, so I can rewrite this term as 3 times the square root of 2 minus 6 square roots of 2. And now I have like terms. I'm going to keep the square root of 2, and I'm going to say 3 minus 6 and get negative 3. So here's my answer here. And my last example, I see that my index is the same, 2, 2, and 2, but my radicands are all different. So I'm going to break down each one and hope that I get some similar radicands. So for 243, using the border method, I know 3 goes in that 81 times, 3 goes into 81 27 times, 3 goes into 27 9 times, 3 goes into 9 3 times, and 3 goes into 3 once. So since the index is a 2, I'm circling groups of 2. So 2 3's come out. 3 times 3 is 9, so I have 9 radical 3 is what the square root of 243 breaks down into. Square root of 27, using the border method, 3 goes in 9 times, 3 goes in 3 times, 3 goes in once. Again, I want groups of 2 since the index is a 2. So out comes 3, and left hand side is a 3. And the sign here is a plus, so I'm going to put a plus in between. And the last one is 50. I know 2 goes into 50 25 times, 5 goes into 25 5 times, 5 goes into 5 once. Again, groups of 2. So a 5 comes out, a 2 is left inside, and our sign here is a minus. So my only like terms are going to be these square roots of 3. So I'm going to say 9 plus 3 to get 12 square roots of 3 minus 5 square roots of 2. And that's as far as I can simplify that. Those are not like terms, so I can't combine it any further. This is my answer. The objective we're looking at here, if I just scroll up a little, is that I can add and subtract radical expressions. Alright, so I want you guys to try these next 3 problems. So 1, 2, and 3, go ahead, simplify each expression. You might want to pause it so you can copy it down, and then we're moving on to multiplying on the next couple slides. Alright, so when we go to multiply radical expressions, we want to first check to make sure that the expressions contain the same index. And here's some 4 examples. Make sure that they're all like the same square root, or they're all cube roots, or they're all fourth roots. We're going to multiply numbers inside of the radical together and numbers outside of the radical together. So outside numbers stay on the outside and inside numbers stay on the inside. So the same rule as before. If you're in the house, nothing can get inside. So only numbers inside can be inside, numbers outside stay outside. And the numbers outside are called the coefficients, the number inside are called the radicands. Our last step is just to simplify. Alright, so in the first example, I see that they have the same index, they're both cubed roots. There are no numbers outside, so the numbers inside I'm going to multiply, and I will get the cubed root of 3 times 12, which is 36. And then I'm going to go and see if I can break down 36. I'm going to use the border method. 2 goes in 18 times, 2 goes in 9 times, 3 goes in 3 times, and 3 goes in once. In order to leave this radical, I need to leave in groups of 3 since my index is a 3. And I don't see any groups of 3. So I can't simplify this any further, and this is my answer. Go ahead and you try this one. Looking at my next example, I'm going to multiply my numbers on the outside, so it's just 2. And when I multiply my numbers on the inside, because I can, because they have the same index, the index here is a 2. Inside, well, I have a 3. When I multiply my x's, since those are like bases, 3 plus a 1 here gives me 4. And when I multiply my y, since those are like bases, I'm going to add 5 and 6, and those will give me 11. Now I'm going to look to simplify. I know I cannot simplify 3. However, x, there's 4 of them. And remember, our rule here is to divide by our index, which is a 2. So I have my 2, and then 4 divided by 2 is going to be 2, so x squared will come out with no x's left over. And then looking at my y's, dividing that by 2, 11 divided by 2 is 5, and left over inside we have the 3. We have no x's, but there is one y left over inside. So here's my answer for the third one. And you guys try this last one. Remember, in order to multiply radical expressions, they must contain the same index. All right, and we have one last slide, so stay with me. All right, when we multiply binomial radical expressions, we do exactly what you think we would do, which is to double distribute. So that's our first step. Our next step is to simplify. So when we do this, when we go to simplify, we might have to add or subtract common or like radical expressions. So we have to keep in mind how we do that. So in this first example, I'm going to say 4 times 5 and get 20. And then 4 times 4 radical 2. And again, since this 4 is outside, it can only multiply with what's outside. It can't touch this 2 on the inside. So I'll get a positive 16 radical 2. Now taking the second term, 2 radical 2 times 5. Again, this 2 is on the outside and this 5 is on the outside. So they'll multiply together and give me 10 radical 2. And then 2 radical 2 times 4 radical 2. Outside with outside, so 2 times 4 gives me 8. And then the square root of 2 times square root of 2 gives me the square root of 4. And now I'm going to look to simplify all of this. So I see that I do have some like terms here in the middle. They both have the square root of 2. So I'm going to combine their coefficients. So this 20 comes down, I get 20 plus 26 radical 2. And then I also see that the square root of 4 here is really 2. So this is like 8 times 2. And I know that that is 16. So that gives me 2 more like terms, 20 and 16. And I get 36 plus 26 radical 2. I can't combine this anymore because this term has a square root of 2 and this one does not. So this is as far as it goes. This is my answer. You guys go ahead and you try this middle one. And I'm going to go ahead and do this last one because hopefully you notice that these are conjugates. And multiplying conjugates is much easier than multiplying just regular binomials because instead of doing all of FOIL, we just have to do Florida. So first term times first term is 16 and last term times last term minus the square root of 25. And I know the square root of 25 is 5, so 16 minus 5, my answer is 11. All right, you guys, that is it. The objective here that we're looking at, just so you can see it, I can multiply binomial radical expressions using double distribution, and I can multiply conjugates. All right, thanks for watching. I'll see you in class.